from G7 Summit.
ఆకాశవాణి విశాఖపట్నం కేంద్రం ఇప్పుడు ఆంగ్ల ప్రసంగం వింటారు. అంశం ఎన్విరాన్మెంట్ అండ్ హజార్డ్స్ ఏ హోలిస్టిక్ అప్రోచ్. డాక్టర్ బిఎల్ నరసయ్య గారి ఆంగ్ల ప్రసంగం వినండి.
This is the Visakhapatnam station of All India Radio. In tonight's Talk in English program, we bring you a talk on Earth, Environment and Hazards, a holistic approach. Talking on the subject is Dr. B.L. Narasayya.
Earth in solar system as a planet. The only Earth is uniquely placed in the solar system at an optimum distance from the sun and with its own specific parameters like revolution, rotation, tilt, etc. as related astronomical ones. Our Mother Earth has further distinctive features and environments favorable for life, such as liquid water, optimum thermal fabric, energy regimes, along with chemical constituents. Its process integrals, such as the rocky layer configuration, the crust, the enveloping atmosphere, the hydrosphere, including ocean basin, all allow a sustainable biosphere, including the supporting marine and bioplant kingdom. All these are thus attributes of the environment in its widest sense. From the gross environment, inclusive of the entire setting of our Mother Earth, we now further progress down to the meso and micro-meso, and that too in relation to humans at large. Many phenomena we observe commonly are either due to Earth's intrinsic processes or even man-made interferences, all possibly disrupting the ecosystem. What is the internal dynamic structure of the Earth? The Earth is a member of the inner planetary group of the solar system, a spherical, rocky, iron-rich planet with an internally layered structure. The age of accretion of the planet is assigned to be around 4.5 billion years. The topmost layer is crust, underlying by a thick mantle, and further below by an equally thicker core. The nature and composition of these layers widely differ in that the crust is a solid, more or less granitic, and the mantle, the source for volcanism, is also solid but basaltic, more heavy. The core has an inner and outer parts. Inner part and outer part differ again. The outer core is a liquid of nickel iron with a few other constituents, while the inner core is solid. The pressures and temperatures at the core are immense. Core processes, convective currents along with huge dynamo effect are causatives for magnetism. Pioneering holistic investigation. Charles Darwin, world's famous naturalist and originator of the theory of evolution, had once remarked that nothing, not even the wind that blows, is so unstable as the level of the crust of the earth. He happened to observe an earthquake while his ship HMS Beagle was berthed near a Chilean town Valdivia on 20th February 1835. A nearby area, Mount Osorno, also witnessed volcanism on 17th January. So universal was his interest at a young age, he measured the elevations of earthquake-affected areas. In his further scientific studies, spanning over a long time, he observed atolls, their characters, and also birds, tortoises, etc., for their behavior in different islands. All these laid a strong base for his theory of evolution, a breakthrough. He carried with him in his cruises a fundamental book on principles of geology, volume 1, written by Sir Charles Lyell. Darwin was thus a naturalist and an environmentalist. Another prominent scientist, Alfred Wegener, a German meteorologist, came forward with the idea of continental drift in 1912 and provided his evidences through reconstruction of margins of continents. But driving forces and dynamics are not fully backed at that time. Later scientific advances and marine exploration gave needed strength to his original ideas and hypotheses, with a balance on a new concept called plate tectonics. The Earth's upper layer, the lithosphere, is made up of plates, macro to small, continental or oceanic or both, and the plates in continuous motion. With further evidences, this became a globally leading hypothesis explaining the worldwide distribution of earthquake volcanism and beyond. It is remarked that volcanism is a widespread phenomenon both on land and on the ocean floor. Pacific ocean floor is dotted with thousands of volcanoes. It is pertinent to know that crater surfaces, impacts, and volcanoes are common to many planets. Regarding other planets, volcanism was reported on Venus and Mars. Moon, a satellite of the Earth, had prominent volcanic phenomena. There are other distinctive styles of volcanism on some other planets and their satellites, such as even sulfur volcanism. Worth noting, volcanism would at times lead to rich mineralization. An example present day is Papua New Guinea and gold mineralization. Recently on the seafloor, noticed close to the land. Many rich mineral deposits were due to mainly volcanics and volcanism in the geological past. Further, environmentally, volcanism would be considered to affect atmosphere as well on global scale. It could be visualized by Tambora, Indonesia volcanic emissions in 1815. Dust emitted by volcanoes would have the effect of blocking the atmosphere. Such effects were noticed in far-flung areas thousands of kilometers away. Vast dust emissions and atmospheric changes would bring about drastic reduction in temperature. Earth had undergone repeatedly both volcanic episodes as well as glaciation in the geological past. Earth had undergone a number of magnetic reversals as well in the geological past, as deciphered by the records. Cosmic body and impacts. In addition to these events, Earth had a prominent record of a past asteroid impact, such as at the end of Cretaceous, 65 million years ago. Such an impact possibly had disastrous consequences, including radiation fallout, leading to widespread extinction of the then mighty and prevalent dinosaur species. Such mass extinctions of species were many times in the geological past. Another example of a meteorite fall in central Siberia on June 30, 1908 resulted in clouds of fine dust blocking thousands of miles away, heat and radioactivity. Earth receives solar radiation, which provides light and heat. Eternal heat of the Earth is another feature. Geothermal gradient, that is the rate at which it increases with the depth, is a characteristic feature and depends on geological terrain. There are locales like Iceland and New Zealand where geothermal heat is exploited for geothermal energy potential. Iceland is sitting on a volcanic chamber. Another very characteristic feature is radioactivity. That means the relative instability of the parent nuclei. Uranium, thorium, potassium are some radioactive elements. Uranium and thorium have a potential value as nuclear energy source material or even for nuclear weapons. Environment over geological time. Earlier was in high thermal condition and slowly started cooling. The early Earth atmosphere was also different. Constituents such as C, H, and their combinations like ammonia, carbon dioxide, etc. dominated. The early ocean absorbed CO2 to a large extent and saved the Earth. Oxygen proliferated only at a later stage with the onset of photosynthesis. Slowly the atmosphere, now secondary, was oxygenated, although nitrogen is the dominant constituent. From around 3 billion years ago, of humans belongs to the youngest geological age, quaternary, roughly around 2.5 million years ago. There were glaciations in the epoch, including the present one, around 10,000 years ago. Our base, the Earth's top zone, the crust, and the soil horizon therein are the main repositories and resource base for all the life forms and biota, including providing nutrient elements. This is the substratum for the biosphere. Marine is prolific with other life forms which are distinct. There is continuous interaction between the lithosphere, solar radiation, hydrosphere, and the atmosphere, which propel the systems and result. Climate, it means rain. Climate is the summation of different variables qualifying a weather or province or general nature. The macro parameters controlling the planet's climate are the tilt of the Earth's axis, the solar radiation received in different regions, the uneven heating of the land masses and oceans, etc., together with wind patterns. The temperatures of the Earth average had not remained constant or the same throughout. Ancient oceans had a high thermal nature, about 50 degrees. Subsequently, oceans have cooled over time. Presently, the average temperature of the Earth is around 15 degrees, despite large variations across polar and equatorial regions. Earth in its geological past, however, witnessed intense spells of aridity as well as glaciation over times. As climate is essential prerequisite for the entire life kingdom and much more for the human, it is but reasonable to look at the dimensions of the climate change perceived as a threat, causing disastrous consequences like sea level rises on a longer time scale, global warming, and such events, development with disequilibrium. While there are needs for industry and society, should it be for our generation or otherwise, the necessity of raw materials compels excavations or even mining activities for the required commodities. On the sidelines of such activities are collateral to the same. It has to be properly evaluated. The dangers are not aggravated by excessive deforestation, catchment area destruction, oil sand extraction, and hazard to fragile and sensitive zones bordering coastal lines and prescribed bioreserves and biodiversity. Noticeable or the alarm bell on the continuous production of coal-based power plants, mainly and thereby effluents releasing greenhouse gases. Greenhouse gases, CFCs, affect the protective ozone layer of the Earth as well, which is the shield from ultraviolet radiations. Ahead into future. During the observations over the last century in particular, regarding the pre- and post-industrial era, concerns have been advocated in terms of increased CO2 levels from 280 ppm to 360 ppm in the atmosphere, progressively on the higher side, and the thermal hiccups linked to greenhouse gases, which include a few others, and also carbon dioxide, methane, nitrous oxide, and modern hydrofluorocarbons. No doubt weather or climate change are perceptible worldwide, resulting in reports of unusual incidences of rainfall in metros and flash floods endangering all susceptible locations. These are a few affecting losses to economy, agriculture, livelihood, and even biota. The crux of the problem is again related to the continuous energy dependence, particularly on fossil fuel resources and energy therefrom causing greenhouse gases, thereby accelerating global warming. Non-renewable resource energies are the only root remedies. Earthquakes prediction is still at large. Awareness is the way, and advanced countries disseminate the right knowledge, recognizing communication, rescue, rehabilitation, etc. Volcanic areas normally active would have their traces and precursor signs prior to eruption. Those around need all mitigation and rehabilitation measures. Data about meteorites is possible through science advances. Tsunamis present advances to oceanic sensors could be forecast in advance. Rescue and rehabilitation had to be in place. Floods, cyclones, hurricanes, modern satellite imagery, and sensors yield quite advanced prior information. Proper communication is needed to reach the target population. Unprecedented floods and flash floods are international category. Long-range effects of global warming, sea level changes need long-range remedies, in particular towards the reduction of the main greenhouse gas, CO2, in the atmosphere by appropriate environmental protection and energy utilization only. Non-conventional resources and nuclear remedies with all regulation and hydrogen economy are other viable future routes.
You have just heard a talk on Earth, Environment and Hazards, a holistic approach by Dr. B.L. Narasayya. It came to you from the Visakhapatnam station of All India Radio. Do stand by for the next announcement.